Section 4.3, Transformations and Congruence. This is an introduction to this whole idea of transformations that we will actually revisit several times throughout this geometry course. So let's first define what transformations are. Transformations in the plane. So remember, a plane is just a flat surface. So again, transformations in the plane move or change a figure to produce a new figure. So this would be like taking a triangle and reflecting it over some line to get a new mirrored image of that original triangle. A rigid motion is a transformation that preserves length, angle measure, and area. So what that means is a rigid motion does not change the length of any of the sides of whatever figure that you're changing. It doesn't change any of the angle measures inside the figure that you're moving or changing. And it does not change the area that the polygon or whatever you're moving or changing, it doesn't change the area inside of it. And there's actually three kinds of rigid motions that we are going to examine in this section. And those are translations, which is just shifting or just sliding a polygon or whatever the figure might be across a certain distance. Reflections is another kind of rigid motion, and this would be like what we were talking about before, taking a figure that's maybe on the left side of the y-axis and reflecting it over the y-axis, so now that it is a reflection or a mirror image of the original figure now lying on the right side of the y-axis. And rotations is the third type of rigid motion that we will examine, where you literally just take a polygon or whatever the figure you are working with and rotate it, like spin it in a certain direction. So again, translations, reflections, and rotations are the three kinds of rigid motions that we are going to examine in this section. Remember, rigid motions do not change the length, the angle measure, or the area of the original figure after you transformed it. So again, translations, reflections, and rotations, they're transformations, but specifically they're rigid motions because the original polygon does not change as far as its length, angle measure, and area go. Recall that two figures are congruent if and only if corresponding sides and corresponding angles are congruent. This is exactly what we were talking about in the previous section. Two figures are congruent if their corresponding sides and corresponding angles are all congruent. Therefore, two figures are congruent if and only if there is a rigid motion or a combination of rigid motions that moves one of the figures onto the other. So remember, rigid motions do not change the side lengths, the angle measures, or the areas of the figures that you are moving or changing. So therefore, two figures are congruent because you're not changing any of the angle measures or any of the side lengths if there's a rigid motion or a combination of rigid motions that moves one of the figures onto the other. So in this graphic that I took a screenshot of out of your book, it says congruent figures and transformations. Two figures are congruent if and only if one or more rigid motions can be used to move one figure onto the other. Exactly what we were saying up here. If any combination of translations, reflections, or rotations can be used to move one shape onto the other, the figures are congruent. So what I want you to write down in your notes, that translations are just shifts from one figure to the next. You're just sliding it over. So in your notes, write down that translations are just shifts. So again, translations are just when one figure is shifted to another spot away from the original position. A reflection, and again, I would write this down in my notes, is when you take a certain line and you reflect an original figure over that line so that your new picture is the reflection or the mirror image of that original figure. A rotation is when you take an original figure and you rotate it about a certain point. It could be a point on the figure itself or a point outside of it, and you rotate it a certain number of degrees so that you have a rotation of the original figure. Again, I would write all of that down in my notes. Translations are shifts, reflection is when I have mirror images, and rotations is just when I spin it about a certain point. Example number 1, describe the transformation or transformations you can use to move figure A onto figure B. So just to be clear, figure A is your original and figure B is your new. This dotted figure is kind of a transitional picture on how you would get from A to B. So looking at this, A is first rotated about point P so that it becomes this dotted figure. So we first have to have a rotation about point P. So again, I'm rotating about this point, turning it this way, and then to go from our dotted figure onto figure B, I have to reflect it across that line. So it's a rotation about point B and a reflection across the vertical line. So again, our combination of transformations was a rotation and a reflection. And finally, we have example 2. Explain why figure A and figure B are not congruent using transformations. So let's take a look at the diagram. We have figure A, which is our original, and figure B, which is the new. It looks as though figure A is first rotated this way about point P, and we get this new transitional picture, the dotted picture that has been rotated. Then it looks like they took this dotted picture and they reflected across that vertical line so that I have a mirror image of it. However, if you look at figure B, it's this solid portion. Notice that figure B and our dotted portion, they do have one side that is congruent. However, this side of the dotted picture is not the same as this side of figure B. The same goes for this side here of figure B. It is not the same as the dotted picture right here, and there's not even a segment up here on the dotted picture that is congruent to figure B. So just to kind of sum all that up, remember we rotated figure A about point P to get this image. And then we reflect that image over the vertical line to then compare it to figure B. And while making that comparison, we see that although one pair of corresponding sides is congruent when you look at figure B and that image that was reflected, none of the corresponding angles were congruent. Like this angle is not congruent from figure B to the dotted figure. We also see that the rest of the sides of the dotted picture are not congruent and or corresponding to those of figure B. Therefore, we can state that the figures are not congruent. And that's actually it for this section. It's pretty short, so make sure you jot down anything you didn't understand so that we can cover that before we move on. Again, remember what a rigid motion is. All 3 types of rigid motions, the translations, the reflections, and the rotations, and make sure you're going to be able to identify when a rigid motion has taken place. And we'll see you then.